Welcome back to Inorganic Tutors Institute. In today's lecture, we are basically going to look at one of the most important topics in mathematics. And guess what? Can you type one of the most important topics in mathematics at the comment section? 1, 2, 3, 4, 5. All right. So one of the most important topics in mathematics is called set theory. Set theory. So basically, set theory is the language of modern mathematics. All right. So without understanding set theory or without understanding set, it becomes very difficult, or one cannot properly understand what we call functions. One cannot properly understand what we call limits. One cannot properly understand what we call continuity, and one cannot properly understand what we call probability and analysis. Now, we are going to start from the very basics to the advanced level. Right. So we are going to begin with in this episode, all right, we are going to talk about only 3 things. We are going to talk about the definition, we are going to talk about the notations, and then we give examples, and I'll give you some trial to, enjoy at home. All right. So with episode 1, we look at the definition, notation, and examples. Okay. So the larger headline is union and intersection of what? Sets. So we begin the definition of a set. Definition of a set. Right? So if we talk about a set, how do you understand a set? How do you define a set? So basically, a set is a well-defined. The underlined word is a well-defined. So a set is a well-defined collection, all right, collection of distinct objects called elements, of distinct objects called elements. So the underlined word here is defined, well-defined, distinct, and elements, right? So this is all what a set is about. Once you are able to understand the basic definition of a set, anything in mathematics becomes very easy for you, because that is the language of mathematics. Now, once you understand the meaning of a set, let's look at why we underline the word well-defined. Well-defined. So well-defined means when we talk about well-defined, we are trying to say that every object that you see must be clearly determined, right? Every object that you see must be clearly determined without any confusion, right? So every object that you see must be clearly determined. No confusion, or without any confusion, right? So well-defined means every object, right, must be clearly determined. The underlined word here is clearly determined and no confusion. So these are the preliminaries of the sets. Now, once we have this concept well synced in, let's look at some examples of a set, right? So we look at examples, right? So a clear example is A equals curly brackets 1, 2, 3, 4, close curly brackets, right? This is not a bracket, this is called curly brackets. Curly brackets. The word is curly brackets. Curly brackets. So the word is called curly bracket. The notation here is called curly bracket. We will get there, all right? So that is it. Now, I want you to understand each of the statement here. I want you to understand what A means here. I want you to understand what the element in the set means. Okay, so the object, all right, the objects 1, 2, 3, 4 are called the elements. Are called the elements. Then we write elements. Inside the curly brackets. We write elements inside the curly brackets. And thirdly, the letter A is the name of the set. And thirdly, the letter A is the name of the set. So the A you see right here, this symbol A, is the name of what? The set. So we call it set A. Set A, right? So it's called set A. This set is called what? Set A. Now, the objects 1, 2, 3, 4 are called the element. So you see the element here. You see, I understand. I really underlined the element, the key word here, element. So the element 1, 2, 3, 4, these items are called element. And we write the element inside a curly bracket. Okay? We write the element inside a curly bracket. So you see the 1, 2, 3, 4, they are elements, and we write them inside a curly bracket, not a bracket, inside a curly bracket. Know the difference. We have brackets and we have a curly bracket. Don't confuse them, right? Now, let's look at some example that is not a set, all right? Now, we know that this is how a set should look like. Now, let's look at an example that is not a set or non-example of a set. So we call that one example 2. This is example 1, right? Example 2 is non-example or non-set, right? So with that one, I'm going to give you a very simple example. B equals beautiful girls in a class, or beautiful girls in a class, right? So that is the set name. B equals beautiful girls in a class. All right, so this is a non-set or non-example of what? A set. It's not a set at all. If you have something like B equals curly bracket into bracket what? Beautiful girls in a class, this is not a set. Why? Beautiful here is subjective. The word beautiful is subjective. Something that someone prioritizes, another person does not prioritize, right? So if, for instance, you say that I'm very handsome, another person might say that I'm not handsome. Another person might say that it's moderate, right? So the word beautiful or handsome is subjective, right? So we say that this is not a set, right? Because it is not well defined. It is not well defined. It is not well defined. So that is what it is making it not to be a set. Now we look at element of a set. Element of a set. This is where the game is becoming interesting, you know, right? So we are going to look at notations, how we're going to play around notations. And you know that this is what you have to use here, this is what you have to use here, this is the name of this notation and all that. So I'll be very glad you can glance through this again, because this is the basics of set theory, right? So if you get this right, any other thing that follows up becomes very easy for you. Now, we are going to look at the notations, right? So, for instance, if an object, all right, an object say X, right, belongs to a set A, then the notation is going to be, so for instance, if an object, so let me write notation first, right? So notations, element of a set, and I write notations. So first of all, first thing we are looking at notation is that if, for example, if an object, let's say X, right, belongs to a set called A, or a set called A, then we write that as X belongs to what? A. This long English right here is the same as this. So mathematically, someone just write this, and if you are mathematically inclined or you know the basics of mathematics, you know that this right here represents the whole of this statement, right? So X belongs to what? A. And that is the notation for this statement. 2. If, for instance, we say that an object X does not belong to what? A, then, so if an object X does not belong to a set A, we write that as X does not belong to, so you see the way we write it, we just cross it with a slash, right? So does not belong to A. So this whole statement right here can be represented mathematically like this. Okay? So understand the basics of mathematics, and then you write your problems in mathematical language. Now, let's look at some examples, all right? So let's look at some examples, all right? All right, so perfect example of a notation, all right? So example. We are going to look at the notations, right? Examples of notation. So example 1, let's say that A is equal to 2, 4, 6, 8, right? 2, 4, 6, 8. And then we can boldly say that, right? We can boldly say that 2 belongs to what? A. That is perfectly right, right? Because 2 here is a member of what? The set A. So remember, from the beginning I said that A is the name of what? The set. And the element or the items inside the set is called what? The element. Alright? So 2 is a member of what? A. So 2 belongs to what? A. And this is how we represent it. Now, can you see that 5 is not here? 1 is not here. So we can say that 1 is not a member of what? A. Right? So this is how we note it. 1 is not a member of what? A. 2 is a member of A. 4 is a member of what? A. Right? 6 is a member of A. 8 is a member of what? A. But any other element apart from these items are not a member of what? A. Period. That is so interesting, right? So that is basic thing that you have to know in here. Now, let's look at some important things that you have to know under the notations, right? So basically, the 2 we see right here is an element, right? So the 2 that I said is a member of the set A is 2 is an element, okay? 2 is an element. Second point, if you put 2 inside a curly bracket, then it is no more an element. It is what? A set. Get that clear. If you put 2, let me use red ink, right? If you put 2 inside a curly bracket, right? If you put 2 inside a curly bracket, right? If you put 2 inside a curly bracket, it becomes a set, not an element. Not an element. So if you see this is a set. This is not an element because you have used a notation called curly bracket. But if you write just 2 without any curly bracket, then it means that it is an element. Great. Now, once you have understood this basic concept, then let's proceed with some other important properties of set. Great. So we are going to look at some properties or some important properties. Of course, we have so many properties, but we're going to look at some important ones of a set. So important properties of a set, right? Important properties of a set. So 1, the order, all right? The order does not matter. The order does not matter, right? So for instance, if you have 1, 2, 3, it's the same as 3, 2, 1, right? So when it comes to sets, where you arrange or where you put 2 or where you put 3, it doesn't really matter. It doesn't matter at all. It doesn't matter, right? You can put, so you can see that we have 1, 2, 3 in this order, right? This is in order, right? But in here, it is arranged in descending order. In here, it has been arranged in what? Ascending order. So it doesn't mean this is not a set. This is a set and this is a set. And they are all the same. They are all the same because they have the same element inside it, right? So this is a set and it is equal to this. So that is one key property of a set. Order does not matter. Now, let's move up here. I want you to get the basics very clearly so that when we move on to episode 2, you won't get yourself confused. Because we are going to go about 8 to 10 episodes before we get this particular topic done. So I want you to get the very basics very well so that as we climb higher, you become stable. So the second important property is we don't prioritize repetition. No repetition. And we are defining a set, we don't need repetition. Kwame is here, Einstein is here. No, we need only Einstein, not Einstein, right? So no repetition. Take care of that. So for instance, you have one, right? 2, 3, right? This is basically the same as someone writing 1, 2, 3. Right? So if you write this, it is the same as this. You are just wasting your time. So repetition is not needed in sets. So when we are talking about a set, we no need, or we are not interested in repetition. So someone writing this is the same as someone writing that. So this one, we count this one as 1. So 1, 1 is the same as 1. 2, 2 is the same as 2. 3. Great? So don't repeat items when it comes to sets. Don't repeat items when it comes to what? Set. The third key property is elements are distinct, right? Elements are distinct. And you know, when we talk about distinct, the word distinct, you have to understand the word distinct, right? So the third property is that elements are distinct. So you can see from here that each element is distinct. This is 2. We don't have anything like 2 again. Like if you are talking about 2, we only know 2 as 2. So 2 is distinct, right? 2 is distinct. So when you look at something like natural numbers, they are distinct. 1 is 1. When you talk about 1, we know that 1 is 1. When you talk about 2, we know that 2 is 2, right? So elements are distinct when it comes to what? Set. So each object appears once only. So that is the element are distinct. Each element appears once only. That is, elements are distinct. So under the element are distinct, we say that each element appears once only. And the second point is that, so basically under the element are distinct, we say that each element appears once only. And that is the basic explanation I gave here. So you can see that this is appearing 2 times and we consider it as 1. So because we are talking about distinct, a set is a distinct one. This is appearing 2. We know 2 as 2, so we pick only 1. Then we bring out 3. So that is what we mean by distinct. Distinct, right? You have to underline that word, distinct. Distinct. Great. This is so interesting, right? I believe you are enjoying the lesson. Now, what is next? We are going to look at ways of describing sets. Ways of describing sets. So, the next topic is ways of describing sets. Ways of describing sets. So we are going to look at some few ways that we can use to describe a set. So as you are, you know how you describe yourself. If someone asks you, can you give us a little bit information about you, say you begin to rattle from basics to advanced, know how you are. Right, so the same way applies to the level of what mathematics, particularly sets. So we are going to learn some few ways that we can describe sets. All right, so the first method, so we call it method 1. All right, method 1. For method 1, we either use the roster, right, or the listing form. Roster or the listing form. Roster or roster, right? Roster or the listing form. Roster or the listing form. So we are going to use either the method 1. So in the method 1, we call it roster or listing form. So from your basic education, you know, when we talk about roster, the meaning of roster. When we talk about roster, the meaning of roster, you know it. And when we talk about listing, you know what the word listing is. So they are all used interchangeably, right? So let's look at some example under it. So basically, under the roster method or the listing method, we say that element are listed, right? Elements are listed explicitly. Elements are listed explicitly. So I want someone to underline the word explicitly, right? So in your advanced mathematics, you will always come across the word explicitly. So when we talk about something explicitly, or if I say that describe yourself explicitly, it means that I'm trying to say that be specific, right? Be specific on your description. So under the roster or the listing form, we expect that elements are listed explicitly or specifically, right? So let's look at some sets, right? A set like A equals 1, 3, 5, and 7, right? So we have been very explicit on this set, right? Unlike this set, there is a particular set. All right, this is a set that is very explicit. We have listed it explicitly because we can see that we have 1, 3, 5, 7. This is what? Odd numbers. Got it right? This is odd numbers. So we have been explicit on the set. We have been specific on the set, very specific on the set, and that is what we call the listing or the roster form. Now let's look at the second form or the second method in describing a set. The second form in describing a set. So method 2 is builder notation. Builder notation, right? So that is the second method. So basically, I have two ways that we describe a set, and that is the first one is the roster or the listing form, where we make sure that elements are listed explicitly or specifically, right? And the second method is builder notation. You know, when we talk about builder notation, we always use it in our daily lives or in our daily mathematical workings, but we don't really know that this is the name, right? So when we talk about builder notation, we have a general form. We have a general form that we represent it, which is the builder notation. We have a general form, right? So the general form the general form is given as A equals this such that X is conditioned. S is conditioned on S. S is conditioned on S, right? Such that, so S is conditioned on S. So A is equal to curly bracket into X such that is conditioned on what? X. Is conditioned on what? X. So let's look at some example. So example is like A equals X such that X is an odd natural number less than 10, right? So this is an example. X is such that S is an odd natural number less than what? 10. So this is the builder notation form. So anytime you see something of this sort, it's called the builder notation form. The builder notation form. And that is the second method that we can describe a set. That is the second method that we can describe a set. Now, let's look at some key important things before we move on to the standard uses, right? So key or important notice I want you to note before we move on. So let's look at some key notes, right? So take note of this. I'm coming to write for you. So some important notes that you have to look at. This thing that we have right here, the symbol, this is called or means such that, it means such that this symbol that you see here, right, it means such that. So anytime you see that symbol in set, it means such that, right? So that is the ways we can describe a set. So ways of describing a set, we have one, the roster or the listing form, where you be very explicit on the element. And the second one is the what? Builder notation form, where you use the builder notation to, describe your set. Now, the next thing on the list is the standard set used in analysis and algebra. The standard set used in analysis and what? Algebra. And specifically speaking, we are talking about algebra here. So the standard set used in what? Algebra. So the next on the list is the standard sets used in analysis and algebra. So we are going to look at them. The first one is N, capital N. That capital N means natural numbers. So this N is equal to 1, 2, 3 up to infinity. 1, 2, 3, comma, 3 dots, right? Up to infinity. So you know how to represent natural numbers. 1, 2, 3. Natural numbers start from 1. No natural numbers start from 0. If you are to count, you don't count from 0, you count from what? 1. So that is natural numbers. So natural numbers from 1, 2, 3 to infinity. So we cannot list up to the end. We don't know where the end is. So we just list 3 dots. right? And that represents up to infinity. The second one is, so let me write it for you. This is natural numbers. Natural numbers. Right. And the second one is z equals 3 dots negative 2 negative 1 0 1 2 to infinity. Right. So this is also called integers, right? So from your basic school, you know that if you see a z, a big Z, you know that it is integers. Put it in your mind. It is called integers. Put it here. Whenever you are dealing with set, and you see Z, it is integers. So we call it integers. Then the third one on the list is Q, right? So we have Q, and that is equal to P over Q, comma, Q belonging to what? Z, comma, Q is not equal to 0, right? So this is called rational numbers. So rational numbers is defined or is described as P over Q. This is what? Rational numbers. P over Q is rational numbers. And the symbol is what? Q. So P over Q is what? Rational number. So if you see a fraction, right? If you see a fraction, it's called what? Rational numbers. Put it in your mind. And Q belongs to what? Z. Q is an integer, right? Q is an integer. And take note, Q is never 0. If you see Z, Q here to be 0, then the thing is not defined. The rational is not a rational number. Q cannot be 0, right? You know that from your basic school, if you have something over 0, this is what? Undefined. This is undefined. So Q should not be 0 in any case. So that is a little bit you have to know about the standard set that is used in analysis and algebra. Now, we are going to look at some common mistakes that you as a beginner can commit. And I don't want you to commit that mistake. So I'm going to put it out for you to, know them so that it doesn't, or you don't commit them, right? So common mistakes, or let's call it common beginners mistake. Common beginner mistakes. So I'm going to use a red ink to write them. So if you see a red ink, means it is what? Danger. All right. So the first common mistake that we do is by confusing element with a set. So from the beginning, you see the way I stress on the word element and a set. There is big difference, vast difference between a set and an element, right? So confusing element with a set or with subset, right? Confusing element with subset. 2. The second mistake that a beginner can commit is to writing repeated writing repeated element. Writing repeated element. I stressed on that, so don't commit that mistake. 3, using square brackets. This is a mistake that most people commit, even people at a higher level of what mathematics do commit. So I want you to avoid this mistake. Avoid using square brackets instead of what? A curly bracket, right? So avoid using square brackets instead of a curly brackets. And the fourth one is writing vague descriptions. So these are the mistakes that you as a beginner can commit, or you as a beginner can try to do. So I've really stressed on that. I don't want you to commit that mistake. So the first mistake you can do is by confusing element with a subset. 2 is by writing repeated elements. Don't do that. 3 is by using square bracket instead of a curly bracket. The fourth one is writing vague description. Don't write vague description. Write a specific or be explicit with your descriptions. Now, I'm going to give you a work because I've done a lot, right? I'm going to give you a work. At this time, I'm going to push you some works, right? Some trial works so that you do it at your comfort zone. So the last thing I'm leaving for you is some exercise, right? Some exercise. So exercise, right? Exercise. So the first exercise is, I want to ask you, or I'm asking you that, is the following set, or is the following a set? Is the following a set? Is the following a set? Explain. Is the following a set? If it is a set, explain. Explain your answer. Make sure you leave it at the comment section. So this is the set. Tall students in this class. Tall students in this class. So this is what I'm leaving for you as an exercise or as a trial work. That is the first one. The second one is write the set of all even natural numbers. Right? Write the set of all even natural numbers less than 12. All right? Write the set of all even natural numbers less than 12. A. In the roster form or the listing form, right? B. In the set builder notation or in the set builder form. In the set builder form. So I've given you 2 trial works or 2 exercises. 1 is the following a set. If it is a set, explain. If it is not a set, to explain. I want to get that at the comment section. The set is A equals curly bracket into tall students in this class. That is the set. Now, The question 2 is write the set of all even natural numbers less than 12. A, in the roster or the listing form. B, in the set builder form. So I've given you 1, 2 exercises. So give it a try and leave your answer at the comment section. In episode 2, I'll provide the answers before we continue, but please try to make it engaging. Leave your answers at the comment section. Let me see how you are improving with your set theory experience. So conclusively, today we are done with episode 1. We studied the definition, we studied the notations, and we looked at some examples of that. Now, conclusively, today we learned what a set is and how to write correctly and the basic language of a set theory. So that is what we learned. And in the next episode or in the next video, we will study types of sets. We will study including the empty set, the finite set, and the infinite set. Now, if you found this video interesting or so impactful, please don't forget to share, like, subscribe, and comment. I really appreciate that. It's the comment section and the subscription keeps me moving. It gives me so much joy. So please, see you next time. Bye-bye.